You know, when you think about a modern factory, it's easy to just see a bunch of machines. But what if I told you it's more like a single living organism? I mean, think about it. It's got a brain, a nervous system, and senses, all working together in perfect harmony. So today, we're going to tear this thing down, figuratively, of course, and see exactly what makes it tick.
Okay, just look at this. You've got robotic arms, automated vehicles, conveyor belts. Everything is moving in perfect sync. It's like this beautifully choreographed dance, right? But here's the crazy part. There's no human choreographer pulling the strings. It's absolutely mesmerizing. So how in the world is this even possible?
Well, the whole secret, the answer to that big question, is that we've given these machines the ability to perceive their world. Which brings us to the real heart of the matter. How do these machines actually see, hear, and feel what's going on around them?
All right, everything has to start somewhere. And for the factory, it all begins with a central command center. Let's dive into the brains of the operation, the industrial control systems.
So what exactly is an industrial control system, or an ICS for short? Well, the easiest way to think about it is as the factory's brain. It's this electronic system that's constantly pulling in data from all the sensors out on the floor. It's comparing that information to what's supposed to be happening, the set points, and then it sends out the commands to make it all work. Now inside that brain, you've got the real workhorse, the on-the-ground commander, and that's the PLC, the Programmable Logic Controller. You can think of it as this super tough, ruggedized computer that takes the big picture plans from the ICS and translates them into direct split-second actions for all the machinery on the factory floor.
But, a brain is totally useless without senses, right? So how does this factory actually perceive its world? Well, it does it through this incredible array of sensors that act as its eyes, its ears, and even its hands.
Okay, first up, let's talk about the proximity sensor. This is basically the factory's sense of touch, but without ever actually touching anything. It just detects when an object is nearby, which is absolutely crucial for simple stuff like counting and sorting products as they're just flying down a conveyor belt.
Next, we have the level sensor. These are a huge deal in so many industries, everything from food processing to chemical manufacturing. Its whole job is to constantly measure how much liquid or solid is in a tank, and that's what prevents really expensive overflows or, just as bad, production-stopping shortages.
Then you've got temperature sensors. In so many industrial processes, heat is the critical variable. So these sensors are basically the guardians of quality and safety. They make sure everything from pasteurizing milk to complex chemical reactions happens at the absolute perfect temperature. And rounding out our list, we have the position sensor. This right here is the magic that gives a robotic arm its insane precision. It tracks every single movement, every angle, down to the millimeter. And that's what enables the kind of complex, super reliable automated assembly that really defines modern manufacturing today. Okay, so that's a lot of different sensors. But that brings up a really important question. With so many options, how do you pick the right one for the job? Well, let's put two common technologies head-to-head and see exactly how engineers tackle a really specific industrial challenge.
All right, here we go. This is a classic matchup for a common problem. Measuring the level in a tank without actually touching the liquid. On one side, we have ultrasonic, which uses sound, and on the other, we have 80 gigahertz radar, which uses radio waves. Two totally different approaches to, well, see the unseen.
So the fundamental difference here is how they work. It's actually pretty simple. Ultrasonic sensors send out a little pulse of sound, and then they just listen for the echo. Radar sensors do the exact same thing, but instead of sound, they use a pulse of radio microwaves. So yeah, it really boils down to sound versus radio waves. Okay, now here's where it gets really interesting, because this is where things can go wrong. Picture a tank that's got foam on top, or maybe the liquid inside is being stirred up aggressively. See that ultrasonic sensor sound wave? It can bounce right off the top of that foam, giving you a completely wrong reading. And in a factory, that's not just a mistake, it's a critical failure.
But this is exactly where radar becomes the hero of the story. That radio microwave signal from the radar sensor, it just punches right through the foam, completely ignoring it, and gets a perfect, accurate measurement of the actual liquid level below. It's a fantastic example of why radar is so often the more robust, more reliable choice for these really tricky applications.
Okay, let's switch gears a bit from process control over to safety. And I want to start with a pretty shocking number. An estimated 90%, that's 90, of all forklifts will be involved in an accident at some point in their lives. 90%. That stat alone makes advanced collision avoidance pretty much a non-negotiable these days.
So here's the problem. A lot of the traditional safety systems out there use something called 2D LIDAR. And the way it works is, it basically sees the world as one flat slice, like a laser beam sweeping back and forth. But that means it can completely miss dangers that are just a little bit above or below that scanning plane. You know, like a pallet sitting on the floor or a low-hanging object from the ceiling.
So what's the solution? You guessed it. 3D LIDAR. Instead of just one flat plane, it captures the entire volume of a space. It creates this real-time 3D map called a point cloud, and with that, it can detect any obstacle anywhere at any height. It is a fundamental game changer for both safety and automation. Okay, so let's recap. We've got the brain, that's our PLC, and we've got the senses, all those different sensors. But for the brain and the senses to actually work together, they have to be able to talk to each other. They need to speak the same language. And this is where communication protocols come into play.
So let me introduce you to IO-Link. It's a standardized communication protocol that has pretty much become the modern gold standard. What it does is allow for two-way digital communication between a sensor and the control system. It's the technology that turns a simple sensor into a smart sensor.
And the advantages here are just huge. With IO-Link, your data transmission is digital, so it's loss-free. You can run diagnostics on your sensors from a computer, which is amazing for predictive maintenance. Installation is a piece of cake with standard cables. And my favorite part, if a sensor ever breaks, you can just unplug the old one, plug in a new one, and the system automatically programs it for you. It's all about keeping that factory running, maximizing that uptime.
All right, so we've covered the brain, the senses, and the nervous system. Now let's look to the horizon for a minute. Where is all this technology actually going? Well, there are two massive trends that are just undeniable. Sensors are getting way, way smaller, and at the same time, they're getting a whole lot smarter.
And this brings us to something called MEMS. That stands for Microelectromechanical Systems. It's this super advanced technology that basically combines moving mechanical parts and electronics on a single tiny little chip. This is the breakthrough that's making it possible to create these incredibly sensitive, super compact, and really cost-effective sensors that, honestly, used to be the stuff of science fiction.
And that leads us to one final fascinating question to think about. We've gone on this journey from simple switches all the way to intelligent 3D vision, and now we're talking about microscopic sensors on a single chip. So, as these components get even smaller, even smarter, and more hyper-connected than ever before, what do you think the factory of tomorrow will really be able to achieve?